Okay, I think we're good in time, so let's go. I'll start. Welcome, everybody. Thank you for joining me here at NDC London. I hope you've all been enjoying the conference so far. I know I will be probably after this lot, and then we get to relax and kick back. So I'm going to hopefully take you through a little journey that I've been going on, building a game engine inside of a product that possibly wasn't originally designed to do it, but hopefully I'm going to share with you why it's actually a really quite good candidate and progress on. And you just have to wait. My clicker has just disabled itself. Yes, I'm hopeful that people do notice that my PS4 controller is a clicker. Like I say, I've built a .NET MAUI app and I've probably got a little too carried away with some of the functionality. Let's go with it. So, as the title suggests, it's a choose your own adventure, so each and every one of you are the character of the story today, and I will be narrating that story. So who am I? My name is Shaun Lawrence. I'm a freelance software engineer and have been working with .NET-based technologies for roughly about 17 years. I've been lucky enough to have been awarded Microsoft MVP, and that's primarily for some of the .NET MAUI community toolkit work that I do with these two guys here. And I was also, I say, lucky enough to be given the opportunity to write a book about .NET MAUI. My publisher tells me off for not promoting it enough. It's called Introducing .NET MAUI, and I do have a copy here that I could give away as part of the interaction today. But I guess the main reason why I'm actually talking to you is this section that I've labelled weaknesses. And that's the fact that I do get distracted quite easily, and I usually chase that distraction down to what's usually typically a deep, deep rabbit hole. I get lost, sometimes stuck down there, and then I typically end up rewarding myself with cake, which I'm starting to realise might not be the best approach. But I am quite keen to try and term the phrase cake-driven development, which I think is going to be one of the next big fads. So a little bit further background of the talk, and then we will dig into the content. I'm very passionate about gaming. I still remember saving up to buy my NES, my first console, in 1992. And that, in a combination with a load of second-hand choose-your-own adventure books from my nan, has helped structure the content today. And actually, I love all aspects of gaming and how it can create environments that we can get lost in, we can escape challenges in life, and just actually start to get some inspiration and potentially create our own. And on that subject of creativity, a large part of why I've done this, I think, is a book that I read very early on in my career, Pragmatic Thinking and Learning, by an author called Andrew Hunt. And it talks about aspects of the brain and how you can potentially you've got a logical side and you've got a creative side. They don't typically function together at the same time. But a way to kind of expedite that process of being in the shower and the answer comes to you is the deliberate shift from the logical to the creative, because you're giving that logical side the time to do its background processing, and then you get an asynchronous callback and the answer comes to you. Sometimes there's belief that you can expedite that process by forcing yourself down the creative route and following that process. So as I did briefly allude to, all of this content is rendered in a .NET MAUI app. I'm hopeful all overlays will work because I've been working on a small screen and I have done a quick test through and it does seem to be okay, so we'll go through that. But as I mentioned, I got carried away with features, and part of that challenge has been because I'm going to let you decide some of the content. That's why it's been baked into a .NET MAUI app, so there's a SignalR connection that we're going to create. You're going to be able to vote. If anyone came to Gerald's talk yesterday, the voting system may look fairly familiar because it is a fork of that. And you will see how you can drive that. And then another point I mentioned, I do have a copy of the book. So when the first voting is completed, one lucky voter will have a little banner to say that congratulations, you've won. So just come along after the talk and you can feel free to collect that copy. So, games. Had to try and get it carried away and implement something that would show off. So this is going to be our environment today. We're going to travel along, learn some bits along the way, and then we're going to get to a couple of forks in the path and decide which way we want to go. And I don't know why he's rendering off the path. If I'm not maximised, he's fine. But as all good games start, we have to have a tutorial. We need to learn our environment and how it's going to affect us. So the first part of that is .NET MAUI. I will keep it fairly quick, brief, because we've got quite a bit to get through. But .NET MAUI, as its full name, is Multi-Platform App UI, which might not be the most inventive, but it kind of does what it says on the tin. And it is a cross-platform framework for building applications that will run across multiple idioms. So you've got mobile, which would be Android and iOS. Then there's desktop, being Mac OS and Windows. And the Mac OS support is provided through Mac Catalyst, which is a piece of Apple functionality that effectively lets you run an iPad app on a Mac with some extra hooks, so you can get the menu bar at the top and some other lifecycle bits. And then you've also got the ability to run the apps on your smart TV or your smart fridge, which is provided. It's not supported by Microsoft, but it's supported by Samsung. And a guy on our team, Jay, on the community toolkit, has sent me some videos of games running on a smart fridge, which is really quite impressive. .NET MAUI, I don't know if anyone went to Rich Campbell's talk before this, but it's fairly young still. It is the evolution of Xamarin Forms. So Xamarin Forms' last major version was 5. The first major version of MAUI was 6, but shortly followed by 7 and now 8. And it's now fitting in with the release cycle of .NET. Now the cross-platform offering by Microsoft now feels like a first-class citizen of the .NET ecosystem, which means we get a lot of fancy features like using the generic host builder, which anyone's familiar if they build ASP.NET web apps. It will actually, I assume the understanding is that you can then reduce the cognitive load shifting between a server-based application and a client-based application because it's all fairly familiar. And then I've got the final point, which is labeled build with the platform, and that's mainly just to highlight the fact that, well, .NET MAUI doesn't offer us everything out of the box, and if we're building a game, it most likely won't. We can interact with the platform-specific layers. We can utilize any of the APIs that Apple or Android offer, like connecting to a game controller, and it just works. Now, a lot of people have asked me why .NET MAUI. Sometimes I ask myself. But I actually believe it is a pretty decent candidate. And I guess part of the journey I've been on is more for the journey rather than the destination of trying to accomplish something. And I find that .NET, I've worked with it for almost 2 decades now. It's my happy, safe place. Therefore, it's allowed me to stay comfortable in the language that I'm learning and kind of expand my knowledge elsewhere in terms of understanding how game engines work. And it already offers us a unified graphics API, so .NET MAUI Graphics, and that delegates down to each individual platform for us. So we end up being able to utilize even things like hardware acceleration, because on Apple, it'll use Core Graphics, and Core Graphics can delegate down and make use of the hardware acceleration if it is available on the device. There's also some fancy features like caching of the canvas, so it can potentially only render the bits that have changed. Now, I don't believe that's baked into .NET MAUI. That's one of my next investigations to see how many render cycles we can save. And I mean, some multiple graphics options, you can actually rip out the .NET MAUI graphics implementation. I originally thought it was Skia, but it's not. It's actually its own implementation. And you can replace it with Skia entirely if you really wanted to. So you've got some options there. .NET's fast. I think with every major release, we see performance improvements. I know with .NET 9 that's coming in September, November, there's a heavy push for AOT, or native AOT, so we're going to only ever see performance improvements rather than any degradation there. And while .NET MAUI is fairly young, .NET itself is a fairly mature ecosystem. It's been around for many, many years. And even .NET MAUI does bring a lot of the learnings from Xamarin Forms. Some will be positive, some will be negative effects, but it is a mature ecosystem. And of course, it's cross-platform, which means we can run it on a multitude of devices without too much effort. So that's covering the kind of the what and the why. So I'm now going to take you a little bit to the how, and this is where my journey's led me to building a library that hopefully someone here might want to use. So it's a fairly lightweight 2D engine. You can achieve some level of fake 3D through shadows or fancy graphics and general movement styles to make people believe that they are in the 3D space rather than the 2D without having to worry about that extra dimension. I mentioned it's built on top of .NET MAUI graphics, so it's delegated down to the platform layers and it gives you all of the ability and the goodness there. And the engine itself breaks things down into two key components. You're going to have a scene, which represents a level. So in one example that we might go into, it's an air hockey table. So that will render the table, and then you're going to have objects, which will be the items moving around on that table. So we have claimed to move along, other than the character. He has shifted by an offset, but not quite where he needs to be. So we're going to keep progressing. We've covered a couple of tutorials, and then we'll carry on. So in order to understand how you can use the engine, you have to take a little step and understand the concepts of a game engine. I don't know if anyone here does real-time application development in terms of real-time systems, like a SCADA-based application. Typically what you end up having is very similar to a game. You have a loop and it just runs continuously. It's quite different to a typical business application where it's event-based driven or interrupt-driven. So what we end up doing is we cycle, and there's only a few steps within this cycle. The first one would be to process user input. So has someone tapped a key on the keyboard or pushed a button on the controller, messed around with the touchscreen. The step after that would then be to update that game state. So you take the input and then you apply some logic based on how long it's taken since the previous update. And then the final step that we would care about is to render that state that's been updated into something visual to the user. There is, on the other side, there's a wait, so you will know that update may be called every 16 milliseconds. It won't be called continuously or constantly. But you don't necessarily have to worry about that. You're informed as you deal with your update and render to know how long it's taken. So if you have a little bit of a deeper look at each of those components, or each of those steps on the right-hand side, we are going to process user input. So like I say, we can use game controller support. And if anyone's used the Apple docs, sometimes they're brilliant, sometimes they're not so good. The controller support is really quite decent. A lot of the game-related stuff is pretty good. You've got the ability to run the paddle boat library, which is Android's equivalent, and Windows does have. I haven't put the name there. It's you can connect Xbox controllers to Windows PC, so there are SDKs out there that allow you to do it. Like I say, .NET MAUI is not going to provide it to you out of the box because at the moment, there's most likely not a lot of value for the team to maintain and support that. And even trying to implement something myself, there's so many different control styles for different games that there's not going to be a one-size-fits-all. You can also deal with touch interaction. That probably should include the mouse there as well, because you get the interaction in a very similar manner. That's all provided to you by .NET MAUI, and all of the touch, so the graphics layer that you use gives you all of the feedback, so you can deal with touches, multi-touch, beginning, ending, and even hover. Obviously, you can't detect that a finger's hovering over, but you can detect that a mouse is hovering over. So that's all baked in. Then there's keyboard support, accelerometer, gyroscope, and actually watching Gerald's talk yesterday, I realised you could even include geolocation in there, so you could build the next Pokemon clone, be the next company to potentially get sued by Nintendo. The second step on our loop would be the updating of the state. So we've processed the user input. We're also going to be told how long it took since the last update. So while we aim to call every 16 milliseconds, if your cycle on the right takes longer than, say it takes 1 millisecond, you may be called back in 15 milliseconds to kind of give you what appears to be a smooth frame rate. So you typically, in this, you would apply a multiplier. So if you're saying, I've got a character that's moving across the screen, I know he has a velocity, therefore I'll multiply that by the time taken, and therefore you can then predict how far they've moved. So you modify state, and the final point with keep display independent, I'm going to mention this quite a few times today because I've fallen into the trap of not doing that. And it comes down to the fact that if you don't keep it display independent, and while it's a fantastic offering by .NET MAUI, it's supporting so many different platforms, you're guaranteed that most devices are not going to be the same shape and size. And actually, even if you rotate the device, the dimensions have changed. Your width is replaced with your height. So if you've got, and look, we can use this. If you've got a drawing game that Gerald did yesterday, which was my previous demo, but I've had to rework that for an air hockey table. If someone was drawing down here and you're storing that as display related, when you then try and translate it onto this side, the person's not going to see it. So you're giving an unfair advantage to people with bigger devices over smaller devices. But if you store it as a ratio, so 0.5 by 0.5 here, translates to the center of the screen on the smaller device. So state should never rely on UI device display information. And then the final step on that loop is to render things onto the screen. So we've mentioned that we use .NET MAUI graphics, and it provides us with a surface that we can draw or we can paint on. So we can then translate what we've created as our game state, and we can translate it into something that is visual and the user can see. And general interaction with the canvas is stack-based. So you would, if you wanted to achieve an effect like this, rather than having to do complicated maths to work out where it needs to be and how to rotate it, you can just say it needs to be here, rotate, and draw. And then you just keep following that, and that massively simplifies some of the mathematics that you have to go through. Going back to my high school, maths has been a challenge in itself. So. Right, we are somehow progressing. The line is progressing, the player not so much. We've covered how, I guess the general concepts. I want to show you a little bit about the engine and how you would use it and how it would fit within a .NET MAUI application, and then we're actually going to break into the sample. The problem is there's a couple of concepts I'd like you to understand before, so it should translate better. So as with, I mentioned, you've got the generic host builder patterns. You get to then add things to the builder. Now, there's just a handy extension method that will register anything with the dependency injection layer, so you don't have to worry about any of that. We then have a scene, which I mentioned there's two key components. You've got the scene, which references to the level, and this is a fairly basic scene that will render two paddles, an opponent's paddle, the player's paddle, and then the puck. So it's the air hockey table, pitch. It is a table, isn't it? And then it's just going to render the lines across the middle and the semicircle. Relatively straightforward. And you have to forgive the shoddy graphics. That is a 16 by 16 pixel blown up rather large. This is the bat from our world map that you can see, and it's just a case of actually just shifting between the images. It's just a sprite, effectively. So you just define how long to do it for, and then it will just keep flashing for you. Now, this can all be wrapped up into a couple of lines in terms of using a sprite class, but I just want to show you the key implementation detail there. I do apologize, Brandon. I don't know if anyone knows, but he's very anti-XAML. But in order to render the game in an application, you will have to put it into the visual tree. And for that, so you're going to render a game scene. There is a view that can display that, so it's called a game scene view. You can put it into any part of your application, any part of the tree, so it could even just be a tiny little component within the app. It doesn't have to be full screen. You can overlay things or put things behind. So if you're building a space game like this one does, and you've got a static image, which might be a large space graphics, it's quite intense to keep rendering. And I know certainly on Android devices, you might experience when you try to render images that are not the exact size that Android wants, you can run into a few performance issues there. So if you render it once rather than in that loop, you can save yourself some performance overheads there. And then finally, in order to start a scene, there's a manager class that will let you start, stop, and load them. and create any instances for you. So if you, like I say, you can register anything with the dependency injection layer, and every time you call load scene, it will create a new service scope and create depending on how you've registered your services, whether they're scopes, transients, or singletons, apply them for you. And it's quite nice to have the scoped, I think, because you can have, say, a ship or a player that exists for the life of that level, and then you can kind of throw away any state that may have been left around and create the next, a new one for the next level. Right, that's it. We are really here at this decision point. And the plan is now going to be, we've consumed a fair bit of information now. I'd like to try and give you the option to either nip into the break room and play on the air hockey table, or we could move over to the right-hand side and we'll dig into the voting system that is going to power the next slide. So if everyone's happy enough to take out their internet-connected devices and navigate to this URL, I'm hoping the QR code provides it because it's not a short URL. Don't worry, it will say voting is closed. As by design, it will only open as I progress through the slide. I don't want anyone, well, anyone not connected? No? Okay. So we've gained a lot of knowledge in terms of the game development, and it's going to now be time to make a decision. We can either stick on that logical side that we mentioned and learn more, go into the voting system, or we can nip into the break room, have a bit of fun, expose that creative side. So if you would be up for... the other thing I should mention is if you were in Gerald's, the voting system will look very similar. So not to spoil anything. There is also an undocumented feature which was in Gerald's again, is the fact that you can keep voting if you refresh the page.
Makes it look like there's more people here.
Okay. I will accept that gaming is probably won, so we can progress on from there. Now, if you not keep refreshing, maybe I should have mentioned that before. Someone may have a banner, or should have a banner that says "Congratulations" on your phone if you've still got it open.
Yeah.
You do? Excellent. So you can. That's okay. If you're the only one that's claiming it, then you can. Yeah, we'll do it at the end of the talk. That's good. I've done testing with like 2 devices and it works, so. Excellent. And you can even implement fancy things like fake achievements as well in your game. So when I start to build something, I always like to write down what it is, maybe draw out a couple of diagrams, and then we'll apply that knowledge. So I've done that exactly here, and we'll just walk through that fairly briefly. So we're going to build, I've written online, we're going to want to build a 2-player air hockey game. So you can have 2 devices that connect to each other and play the game. We're going to match players randomly, or it's going to be a first in, first serve, first come, first served. So one player will join, the next player will join, they'll be matched together, and then you can, in theory, scale up to have multiple games running. That's no problem. Again, we're going to keep it device independent because so many platforms will have different sizes. And we're going to have a central rule enforcer. And this is obviously very important. We don't want to allow people to cheat. It takes me back to a story a couple of years ago when we were all in lockdown. We tried to stay sane or tried to keep our children sane by having video calls, and we even had one session where we played Guess Who between her and one of her school friends. Now, it progressed along quite well. It got all the way to the end, and then it got a bit heated, and there were even questions of cheating. And it actually turns out that some Guess Who sets have different characters in them. So they somehow did not overlap in that Venn diagram. So yes, we had to stop that one pretty quickly. But who knew? So we're now going to visualize that. So we're going to get 2 devices and we're going to connect them up. So one person will move their hockey puck, or paddle, on either side, and it's going to communicate back and forth. Now, we could use, in theory, peer-to-peer or some kind of, so maybe Bluetooth, but I know with Bluetooth you still end up having a server and a client, but it is across device rather than going via a server. The challenge there, though, is, I don't know if anyone else has worked with Bluetooth, it's not the most pleasant experience. And the synopsis of this talk did suggest we're going to be doing SignalR. So we'll scrap that and we'll move to a server. Now, we're going to have a real-time component and we're going to allow our devices to connect to that real-time component, which means the first one can request to play a game, and then the second one can, and then that means they're going to be matched together. Then that means the left-hand side can move their paddle around, and it's going to update on the right-hand side. We don't need to send it back to the other one because that would be an inefficiency. It already knows what its state is because it's told the server. And then we can do that vice versa. Now, there comes a challenge because with SignalR, it's meant to remain stateless. We don't want to hold much in there. So we're going to have to introduce another component that's going to manage that game state for us. And for that purpose, we'll need something in the server, and then that means that it can manage the puck's location and enforce the rules that we just discussed. So if we look at what piece of technology we have in the .NET world, we're going to run with an ASP.NET Core web app, and inside that we're going to have a SignalR hub and then a background service. Now, the reason why they're structured this way is you could actually separate them out. You could put a hub in as your SignalR service. You could put the background service hosted through their mechanism, so you could fit into more of a microservices architecture. But for the purposes of this demo and debugging, just going with a web app to start with is really quite simple. So we've got a couple more tutorials because we've got a few pieces of new technology. So the SignalR, I suspect if people did see the talk yesterday, they may be familiar with this, but SignalR is an open source piece of technology. It's baked into ASP.NET Core now, so you don't even have to add a NuGet package. It offers real-time bi-directional communication, and it handles all of the fancy automatic connection management, scalability, and even the protocol that's used between each connected client in order to determine what's most compatible. So if by default, it will use WebSockets. If WebSockets is not available on one of the clients, it will then fall back to server-sent events and then back to long polling, and then gracefully fail. And it has a multitude of platforms that it does support. So it is the breadth of .NET, including VB, and then the JavaScript and Java as well. So if we take that, and we realize that, all right, you can't see the title, but you can see more of the code. We are going to build a hub. Hub is central to a connection in SignalR. That's where people connect. You think of it as like a distribution center. Goods go in, goods come out. It all goes via the hub. We mentioned that the first device is going to connect and try and play a game. I have removed some of the code for brevity just to make it easier, but if you imagine the group name is just calculated off, it's a GUID basically. So when the first player joins, a game is created, it's assigned an ID. When the second player joins, it sees there is a game that exists with one player, it'll join the two together. That's a fairly standard or basic matchmaking algorithm, but it'll do the job. And then the beauty of how you can use SignalR to connect or interact with your clients, we can group them together because we don't want to tell all other connected clients that someone's player state is updated because they don't need to know that. So we can group them together through groups, and we'll use that group name, which is the ID, and then we can invoke commands down on the client device. So here, what will happen is when a player connects, there's a player connected event sent down, and then once we've got a second player, we will then send down the game has started, and then here's the state. So we're putting the emphasis on the server to determine what the state is and to manage that. So we can effectively rule out some level of cheating. I do understand that the first player doesn't necessarily need to know that a second player, they've connected themselves, but I then use it to know that we've got success and we could show up a kind of a loading dialog. I'm waiting for the next person to connect. And then, as I mentioned, when the player 1 is moving their paddle, they will need to notify player 2 that the opposition paddle's moved, but they don't need to let themselves know. And that's how we can then use the others in group. So that means anyone else in my group who's not me, let them know that this event has happened. Currently, I am using the non-strongly typed SignalR hubs here. You can strongly type them in the ASP.NET world, so you don't have to use the magic strings. You can define an interface that would define the methods you want to invoke, but you don't have that luxury on the client. On the client side, you still have to use the magic strings. So I've just baked it into a constants class, and then you don't have to worry about that. If there's a typo, everyone's got the typo, and therefore it's still valid. And this is then it's a minimal API of a ASP.NET web app. There's two bits that we need to do. We need to add the SignalR dependencies. So while SignalR ships with ASP.NET, it's not necessarily initialized because obviously not every website needs to use it. So we add SignalR and then we map our hub. So that should feel fairly familiar if anyone's used to mapping endpoints or mapping anything within an ASP.NET web app. We tell it the type and where in the URL it fits, with a second quote if you. Right, let's get the next bit done, and then we can actually start to see some action. The background service is another new component, and its task is, so typical web requests are never designed to take long. You don't want to retain state on a server or on a request or a SignalR method invocation. So what we end up doing is there is a concept called the background service that ships with ASP.NET, and you can, its main purpose is to run background tasks. They could be long-running tasks, short-running tasks, but anything that's intense and doesn't need to impact the user, whether that's a caller of an API or whether that's UI. They can be hosted in many different ways. Like I said, you could stick them up in Azure. I forget the name of the hosting service option. You could stick them in a web app. You could probably stick them in an AWS setup somewhere. And they can be started on different mechanisms. So in the web app approach, it will just be started and it will be running continuously, which works quite well for our debugging. But if you're going to move to a more production-based environment, you'd probably ship it to an event-driven system. And then you could maybe use a Redis backend to share the state between the SignalR and the background task to be able to process it and let them know when things are finished. And I mentioned because you've got the multiple ways of hosting, it makes it scalable. So if your game does become popular, it might cost you lots of money in scaling, but hopefully that outweighs or doesn't outweigh the income that you bring in. And for the game worker, I've called it a game worker, but it's implementing the background service. What we can see is it provides us with a base class that we can implement. We can make use of a hub context. That means we can connect to our SignalR hub in our background service. And then all of the magic is hidden away in this process game method, which at the moment, we'll dig into when we get into Visual Studio, because there's a fair bit of it. But in there, we can then manage to say, well, the park state has updated. Let's tell all of the people within this game that it's moved to a specific location. And there's a lot more events that we could trigger, because if you imagine that a paddle's going to collide, we're actually putting that logic of decision-making on the server rather than on the client. So we then need to tell the client something's happened. Then you can provide audio feedback or maybe even haptics to let them know. And back in the initialization phase for the web app, we just have to add that service as what's called a hosted service, and therefore that will just start up when we run the app, and it'll just run continuously until we stop it. Might not necessarily be the most efficient when you move to something scalable. Like I say, you'd probably upload that to Azure and let that manage it for you. Next, we're going to want to connect our client to that, which means we're going to have to make use of a NuGet package. So there is a client-based package provided by Microsoft that will allow you to create a connection. And then to create that connection, we build a connection to the hub. So we use the hub connection builder. We tell it where in the world we want to connect to, and then we build it. And then we can then say, well, anytime we receive a specific event, so the name is puck state has updated, puck state updated. On this happening, I will be given this piece of strongly typed information, and I can then utilize that and potentially update my state. Now, the reason why some of the background information was quite important in terms of the game engine side of things, we don't have to update the UI every time we get an event from the server, which could be a lot more frequently than actually our game loop is allowing us to. So you can actually throttle the level of UI updates that you're doing. You receive the events, you cache them, and then when the next loop cycle comes, you then translate that into something that's rendered on screen. So if you're running on something like an Android device or a fairly cheap device, it can. I brought a Kindle Fire with me here to demo with, but it did decide to transform itself into a paperweight in the hotel room. So I haven't brought that with me here. And then, so you then start that connection, that opens it. If anything fails, if you can't connect, you'll get exceptions, but we can handle those. And then in terms of our game implementation, we're going to then send a method up to the server to say, well, I'd like to play a game. Here's my ID. Let me play. So now we can go and see that in action. Is this size okay for everyone? Yeah. So what you'll see over here, this is Visual Studio Code because I'm running on a Mac, and obviously Visual Studio is leaving us fairly soon. We have 4 projects, tests, because tests are obviously important. We have a shared code library, and actually I'd like to draw some emphasis on how much is in the shared code library, and that's one of the beauties of being able to use .NET on the server and the client. So all of the objects that are passed up and down between the server exist. I've also moved the class that's responsible for managing the state and determining whether there's a collision or managing the whole state of that game in the shared code library. Because with a tiny little bit of abstraction, you can actually have the same code that will run on the client that also runs on the server. So if you wanted to have an offline mode and an online mode, you can run that exact same code on the 2 platforms. You just have to deal, so obviously in the server, you have to send out some SignalR-based events to let the clients know. On the client, there really isn't much to do. You've just got to update some state internally. So and then as I mentioned, there's then a server. So we have our program.cs, we've got the registering of bits, SignalR, the hosted service, the game hub, and we've got the hub here. There's a fair bit more to the hub than, no, there isn't. There's a fair bit more to the, it's there now. We moved it here. So where we now update the game, there is a fair bit of logging when things go wrong because that's proved a bit of a challenge. Then we can potentially update some of the game state, and then we can notify through the SignalR bits that something happened. And this is that level of abstraction that I've put in place, which allows you to then run the same code on the server and the client. So what you'll see is there is a lifecycle handler, which then lets you send out that the puck's collided, the puck state's updated, the score's updated, or it's collided with a wall. So it allows you to potentially send out loads of different events and allow the clients to react accordingly. So they could play a sound or effect. So what we can do is we can run up our server, .NET Run, on the project. That's running, and then we can run up the game. don't want that full screen. All right, we just need a second instance of it. As I mentioned, my Kindle Fire decided to pack it in today. There we go. So we've got 2 instances of the same app. We can now start our game and we can interact with it. And we can then knock it around. It is fairly Pong-like physics at the moment. I did try to throw GitHub Copilot at solving the problem. And as we will probably tell clients, you can't just throw AI at something and expect it to solve the problem. It needs to understand exactly what it is. The code actually looks pretty decent. It's understanding things like mass and how you actually would apply that. So what ended up happening is you barely saw the puck. It was just shooting off at a ridiculous rate. And that's it. That's covered everything. So actually, we could do that in a slide, can't we? Yes. So if we take a look at what we've built, we've implemented server-side management of game state. We've actually got the luxury of being able to run that on the client, as I mentioned, which is really quite nice. Now, we've gone to a lot of effort and we've created a fairly thin client. There isn't really much that the MAUI app is doing, not in the terms of what we've implemented so far, but we do have the ability to utilize other things. Like I say, we could utilize things like maybe vibration when the opposition scores, maybe haptics so you can get a bit more physical feedback. But then we do also have the ability to utilize things like code sharing, so we can run it on the client if we really wanted to. I don't know if anyone's familiar with Bethesda-based RPGs. If you are, you will have seen this overlay many, many times. If you're not, basically, you're given you have a strength, your character has a strength, you have a carry capacity. You're not prevented from exceeding that limit, but if you do, you can't run anywhere, you can't fast travel, you have to just walk really, really slowly. We don't want that to happen with SignalR. We're sending events that need to be fast. So you really want to make sure that you only send the information that you care about. Don't overdo it. So in a previous drawing game that I built, it allowed you to choose a palette of palette of colors, choose a color from a palette of colors. And what it originally did was it would send the RGB string. Now we realize that actually there's a limited number of colors that we let the user choose from. They don't have a full color wheel. They can't define the hex. So you just send a byte that represents the color that they choose, and you're then a lot more efficient. It might not necessarily seem like a big improvement in terms of performance, but when you start to deal with real time and lots of events, then it does all add up. And then to mention, so by default, SignalR will be serialized to JSON, which is getting better and better. It is pretty quickly these days. You can opt to using the message pack protocol, which will make you have, it's binary serialization basically, so you can have smaller packet sizes and potentially faster. There is a caveat that if you're working in an AOT environment, there are some extra hoops you have to jump through to enable support for that, because it does some level of code generation. So you have to generate it and allow that to be compiled in before the app is shipped, because that's not possible in the AOT environment. And then there are a couple of links here that I would strongly recommend checking out. So if anyone's familiar with the well-architected framework that's provided by Microsoft, there's a whole series of recommendations on how you can be more efficient in terms of doing background jobs and queuing and any implementations like that. And then after going down the route of trying to implement my own little server, I did discover that Microsoft offer their own server. And I chatted to some AWS people yesterday, they offer as well. So there is PlayFab that comes from Microsoft, provides you an SDK. It does a lot more of the management, so you can deal with all the matchmaking algorithms. It will deal with all of that for you. You don't have to, but there is a much steeper learning curve. There's a whole separate SDK to get used to. And then there's GameLift that AWS supply, which is another alternative. Okay, so we are progressing. I think our little character is quite keen to get to lunch. So he's getting a little bit closer to the destination. But we'll proceed. So we've got to a second decision point now. So I'm going to ask you to take out your phones again and we can make that decision. We're going to potentially help our little friend the bat. I don't know if anyone needs to scan the QR code or if you've still got it open. Yes, yeah. Yeah, so I'll be honest, with the voting system, I have gone a little state-based at the moment. It does retain the state, that's just why it opens and closes. Now, if I had the ability to render a QR code dynamically, I could generate a group name there, and then we could utilize the same approach that we are using for the air hockey table. Or I could have just generated one in the QR code, but I hadn't thought of that. So we're on our journey, and we've come across a lonely traveller, that's the bat, who is clearly in need of some help. So we can either skip some of our learning, and we can stop and learn a few concepts, how we can potentially make our app more accessible, or we can say, no, I'm going to carry on, my goal isn't too important. So feel free. I think we have a consensus. Hopefully no one can now vote. So we have chosen to stop and help. Now, I myself, I'm red-green colorblind. So I don't know if anyone can see numbers in here. I can see one number. Although to take a step back, I know potentially some of this stuff might not necessarily be game related, but it's a topic that I think is very important to discuss. Because if you imagine that if you make a game that's more accessible, you make it potentially a better UI, a better user experience for everyone. And you also make that group of everyone a bit wider, which means in a very crude sense, if you're charging for your app, you could potentially make more money because you've got a bigger potential user base. But there are obviously lots of other better reasons why you should do it. So as I mentioned, I can see a 12, nothing else. So there are things to consider when you are building games, and I'm currently in the development of trying to build a color-based puzzler, which is ironic considering I struggle. So trying to explore what we could do to make that a little bit better. And this is aimed at showing you how people with different conditions perceive color, which probably should be blown up a little bit bigger. But then what we can do is we can say, well, if people can't perceive color, they can potentially perceive shapes. So you can utilize the two, you can distinguish. So in my example, we're going to probably go with something like this, where we can have patterns rather than color, or both. You can combine the two to give a rather nice experience. And it's becoming a lot more popular these days. Like, I know there's games like Two Dots, many of the other games that are actually building in explicit support for people with visual impairment or some level of challenge. Is anyone familiar with duck typing? Yes? So if it looks like a duck and quacks like a duck, then it is a duck. So if you want to put something on your application that users need to click or tap, it should probably be a button. So the first game that I started to build was it's a space-based game. It's a kind of a cross between asteroids and planetary defense, where you have to navigate a ship around the planet and protect it. And the whole control scheme was baked into the touch implementation, which there was nothing for anyone to realize how to do it. So if you use a screen reader, There is actually nothing presented to the user to actually understand how to interact with it. But you can opt in, you can put buttons on the screen, and then manage your control scheme that way. Now, if you can't find a duck, you can teach it to quack. So in some scenarios, you may not be able to use a button. Styling might not be right. You might not be able to get that floppy disk on the screen. That probably doesn't really have much relevance anymore, but you can do that with an image. And you can give it the ability, people can interact with it through gesture recognizers, and all of that is baked into .NET MAUI. The key detail are those lines 3 and 4 there. So an image is typically background information. It's not something that a user would interact with, and therefore it's not something the screen reader will tell the user they can interact with it. That then means they won't know it's there. If we tell the screen reader or give it hints, we can then actually make it much easier for a user to interact with. I don't know if anyone's played around with screen reader, but it's a testing experience.
What's the difference between description and hint?
Description, it always seems like sometimes, they're very similar words, aren't they? Description is a bit more like a name. So it'll tell you there is a save button. The screen reader will announce there is a save button. And then after that, it will actually read out the hint, and that's telling them what the save button does. You'd think...
It would appear on the mouse over.
Sorry?
It might also appear on mouse over.
Okay, yes, yeah, that's true. And another way they suggest in MAUI as well is if you're building like a form application, I know that's not for games, you can bind these properties as well. So if you have a label that describes, so if you've got a name field and a label that says name, you can bind it to that, and therefore you don't have to keep duplicating your strings. So this guy's obviously getting on quite a bit now. He's been around for quite some time. So let's help him try and find all of those ducks. We'll treat him as a screen reader. There is a hell of a lot more information that we can utilize in order to build accessible applications. So things like font scaling, obviously we're rendering things on the screen, which means by default we probably won't be adhering to font scaling if it's changed, if it's set for a user. So we can hook into receiving that and rendering bigger text if that's what the user has asked for. The other challenge is if you're rendering it in a fixed size environment and you are responding, you might only render part of the text, which makes it even more difficult to read. Many different things to consider. But there are, on the bottom link, there are tools on every platform to allow you to test for this as well. So Apple, Google, Microsoft all provide tools for you to run. And there's even some accessibility checking within Visual Studio now, I believe. And then there's provide multiple modes of interaction, which I've got carried away with, and I'm fully advocating for, is the fact that you can use keyboard, mouse, so then people can use it in the environment that they like, feel most comfortable. It maybe even speech to text, which could be a quite fun one. And then there is non-visual feedback, which I'm quite a keen mobile gamer. Don't know if anyone else is, but you don't get any feedback from a touchscreen. Very, very little. You touch a button on the screen, or you think you've touched a button on the screen, you can't tell. But you could implement some level of feedback through haptics or vibration. Haptics typically offer positive feedback. Vibration is usually something bad has happened, so the player has scored. Haptics, you could even do it as the player clicks on it, so they know they've clicked on it, rather than they think they have, and not get frustrated. You can then also introduce sound effects or background music, which, while video games are mostly visual, things like sound effects and background music really do complete that. And I'll show you hopefully on the world map. So when I put a screenshot up of that on Twitter, someone reached out and said, I've made you a backing track for it. So we can play that at the end. And then you can also interact directly with the screen reader. So while the semantic properties will announce things, if they've got it on, you can announce things directly from your code. So you could announce the score if you wanted to, or you could announce a change in speed or anything like that. Okay, so we're almost there. 2024, I've heard numerous times that it's going to be the year of AI. So I've tried to play around with it to try and make the game development easier. And there are a lot of exciting possibilities. There is you could use storyline creation. If you hit writer's block, you could use ChatGPT. I tried to get it to write something fun, but it failed, so I haven't included that. There's then the physics and the complicated maths or algorithms. You can utilize GitHub Copilot, write a one-line comment, it writes you out a load of code, and then you have to scratch your head and work out what it's doing, but there is value in it. And then there's things like visual design, and this is not subliminal at all. It's not an audience voting green at the end of a conference talk. But you can see, actually, with a sentence, you can generate fairly complex graphics, and you can get quite specific, and it can do really quite fancy things. So I mentioned that there's a Jean-Marie, a guy who makes Sharknado, if anyone's aware, just reached out and said he'd seen the screenshot, and he proposed this over lunch. Some people have a hell of a lot of talent. So this is our journey. We've gone through the break room, we've helped with that, and we're now at the possibility of getting to a shop or a store where we could get something out into the public domain. So that brings me to the end of the talk. There is a URL here that takes you to the repository, and the repository contains the talk because it's what I got carried away with. These are any mechanism that you can reach out to me if you want to get in touch. And I would just say, if you do feel strongly about any voting system you feel, I would love to hear whatever feedback you have. So thank you all for joining me.